So let's look at a few polynomials. For example, I just want to do a basic sketch. I'm going to do a basic sketch of y equals x times x minus 2 times x plus 1. And to do this sketch, I need to be able to go through my list. First, number 1, the polynomial is in factored form already. I don't have any work to do to be able to find my 3 individual factors. So that's done. So the next thing that I need to do is I need to find my zeros. So my zeros are going to occur when the first factor, which is x, equals 0, when x minus 2 equals 0, and when x plus 1 equals 0. And all of these have a multiplicity of 1. So I'm going to write that down. And the reason I'm writing that down is because when I'm referring to my graph above here, I want to make sure that I graph it in the general style of that multiplicity. So once is going to go through the graph. I'm not going to have any bounces, and I'm not going to have any cubic-y looking things. Now my end behavior, for my end behavior, I need to be able to know what is the degree and what is the leading coefficient. That way I can use my chart to figure out what's happening with the ends. Now to identify the degree, we are going to take the first piece of each of my factors and multiply them together. So I'm going to multiply the front portion along with just the first factor, or the first term from this factor, and the first term from this factor. Because if I were to multiply all of this out, that is going to give me what we call the leading term. So if I were to multiply a 1x times a 1x times a 1x, I get 1x cubed. So what that tells me is that I have a degree of 3 with a leading coefficient of 1, which is positive. So I'm going to come back up here. So an odd degree with a positive leading coefficient means my arrows are going to go from left to right. And so I'm going to give myself that little sketch. So based on my end behavior, I know that the arrows have to look something like that. The other little piece is the y-intercept. So now the y-intercept is what happens when I plug in a 0 everywhere there's an x. Because the y-intercept is when the value for x is 0, but I get a value for y. And if I look at this, 0 times negative 2 times positive 1 is 0. So what that means is that my graph crosses the axis at 0, 0 as well. So we're going to use this information to sketch a graph. So for my graph, it's going to be very rudimentary. I'm going to make my x-axis, and I'm going to make my y-axis. And I'm not really going to label the y's much at all, because I really don't have a lot of information as to what the heights of all the individual twists and turns are going to look like for my graph. So it's going to be very basic. And so what I do know is I do know that the zeros of my graph are at 0, 2, and negative 1. My y-intercept is at 0, 0, which is actually already listed, so I'm not going to list it again. And my arrows need to be going in opposite directions. Now, since my zeros are all of multiplicity 1, my graph has to go through those zeros and starting here at this arrow, moving through all of those points and ending up at the top. So that's what I'm going to do. I'm going to go through my 0, but at some point it's going to have to turn and come back down so that I can go through my next 0. I don't know how high up that turn is, which is why I'm not labeling my y-axis. But once it turns and goes down, it again has to be able to turn to go through the other 0 before shooting back up to connect with the other arrow of my end behavior. And so what I'm going to show you is I'm going to show you how you can check this on your phone or on a website. So the website is called Desmos. And so you don't have to have an app for it. You can see up here at the top, it's just desmos.com. And what we can do is we can check to see if our general picture is correct. So I'm going to type in y equals, and I'm just going to type in my equation exactly the way it was given. Right? So I've got x, I'm going to start a parenthesis, x minus 2, and you can start to see this taking shape. And then my other parenthesis, x plus 1. And so this is the polynomial I was given, and this is my general sketch. And now you can zoom in a little bit, and you can look at it, and you can see that it looks very similar to the one I made. Not exactly, not identical, because I didn't know how far down it went to make this turn, or necessarily how high up. But you can see that the general shape is the same. It goes from the bottom, goes up through a 0, and twists and goes down, and twists and goes back up. So without knowing more information, I really couldn't label these hills and valleys. And so that's what we're going to do today, is we're going to practice kind of getting our guide and doing a general sketch, and then we want to check our work with Desmos. Now, it's very important that you use Desmos just to check to be sure you're right and not to cheat and just sketch the graph, because you are going to need to know how to do this on your own without Desmos. So let's look at another one. So now we have y equals negative 2x squared times x plus 1 times x minus 1. Again, this is already in factored form. So the first thing that I'm going to look for is my zeros along with their multiplicities. So when negative 2x squared is set equal to 0, I get x equals 0 as my first 0. But this one, because of the square, this has a multiplicity of 2. So it's not just an x. If I have a factor that has an exponent on it, that means that this has a multiplicity 2. Which is going to be important because depending on my arrows, it's either going to go bounce and go up at that moment, or it's going to bounce and go down. And I don't really know exactly which yet. The other two zeros are at negative 1 and positive 1, and both of those zeros are multiplicity 1. So my end behavior, let's look at the end behavior. Again, I need to figure out what my leading term is going to be so that way I can identify my degree and my leading coefficient. And that way I can figure out my arrows. So again, I'm going to take this first factor times the first piece of each one of the factors. And so when I do that, negative 2x squared times x gives me a negative 2x to the fourth as my leading term, which means my degree is 4 with a leading coefficient of negative 2. And now an even degree with a negative leading coefficient means that my arrows on both sides are going to go down. Again, you can refer to the chart to see that that's going to happen. Now my y-intercept, again, if I plug in a 0 everywhere I see an x, it doesn't really matter what's happening in here. I mean, negative 1 times positive 1 times 0 gives me 0. So this is going to cross, again, at the origin, or at 0, 0, which is already one of my places I'm going to be putting a dot. So let's give ourselves a little bit of a graph. Again, it does not have to be very detailed. The main detail comes from the zeros. So make sure that you give your graph equal hash marks. And we're going to put our zeros as big dots. And the first thing I'm going to do is I'm actually going to put my end behaviors. So with my end behaviors, what I want to do is before I sketch it, I want to kind of look at what's happening. So here is the 0 at negative 1 and positive 1. My graph has to go through. And since it's coming this way, it's going to have to get a sketch going like this. So this is my general picture of what's happening through those zeros. Because of my arrows down here at the bottom, eventually it's going to have to go through in a straight line. The weird one is this multiplicity 2. Right? So with the multiplicity 2, it has to bounce. It can't go through, but it needs to have a bounce because that's what happens when you have an even duplicate. So when I sketch my graph coming from the bottom, it's going to go through my 0, and somehow it's going to turn. It's going to bounce off of that 0, and then turn again before going through and moving down. And so that's my general idea. Again, because the multiplicity of 1 means it has to go through, graph has to go through. A multiplicity of 2 means it has to bounce. And I knew it was bouncing up from here because the graph had to visually just come up and at some point go through. And it can't go through again. It can't go straight through because there's a bounce there. Right? And it can't go through and then bounce underneath, otherwise I'd have other zeros. So again, I'm going to double check this. Right. So I'm going to erase this graph and put a negative 2x squared times an x plus 1 times an x minus 1. And again, we can see the graph looks very, very similar to the one that I've been sketching out. So you're going to be working on a few problems where this is going to be your practice. All right, again, you can check your answers using Desmos on your phone. You don't have to download anything, just we can go to that website. But you are going to be making this list of information.